Hello everyone! In this video I'm going to talk about the different levels or steps when managing food composition data. My name is Fernanda Grande and I'm here to share some knowledge and experiences on food composition with you. So if you are a food composition data user or a compiler, this channel will be very useful for you. So in this video, I will explain all the different steps and activities that should be developed in each level of the management of food composition data. And at the end, I will show you a real example of how I have organized all the data in a food composition table that I have created from scratch. So, especially if you are a food composition data compiler, I really recommend you to watch this video until the end. So let's start with the compilation process. So compilation process is also what we call the management of food composition data, because during this process we are going to manage all the data since the original analytical values until we get the final food composition table that we are going to present to the users. And all this process is what I'm going to describe for you now. So here we are starting with the data source, but in fact the first step in the preparation of a food composition table is to establish the list of priority foods and priority nutrients for inclusion. So once these lists are ready, we can start with the first step, that is the data source. So in this step, we should collect food composition data from many different data sources. So from as many sources as we can. So we should try to get original analytical data that can be published in scientific articles, or we can also try to get data from unpublished laboratory reports. So in many cases, different laboratories, they analyze foods with different purpose, and this data never gets to be published, so we can also collect this information. Additionally, we can also collect data from academia, such as from theses, and we also can collect data from the food industry, so we can try to contact the food industry in a certain country to get data, analytical data, for the foods that are commercialized in the given country. And additionally, we can also collect data from other food composition tables. So it's better to collect as many analytical data as we can from the country, so it will facilitate the next steps in our compilation process. So at this stage, we should try to get as many data sources as we can. So the next step is the archival database, and in the archival database is where we compile all the data that we could collect in the data sources. So at this level we are going to collect original data from different sources. We should not perform any changes or calculations in this data, except for the standardization in terms of units and also denominators. So all the different values compiled from the sources that we could collect in the step 1 should be converted to the same unit and to the same denominator. And when I say denominator, I mean per 100 grams of edible portion on fresh weight basis, because this is the denominator that we use in food composition tables. And additionally, to help in the next step of our database management and of our compilation process, we also need to assign tag names for all the different components. We already have a video here in the channel showing and explaining why we should use the tag names. So if you didn't watch this video yet, I really recommend that you do it once you finish this video, and I will leave the link here. So it is important that we use a standardized tool to compile all this information that we have collected in the first step. So if you don't have a software where you can collect and manage all this information, I really recommend the compilation tool developed by InFoods. This is an Excel tool that can help you to collect all the information in a standardized way and also to proceed with the data documentation. So I will leave the link down here in the video description where you can access the compilation tool. And later on this video, I will show you a real example from a compilation that I did for the Pulse's Global Food Composition Database. And I have used this compilation tool to collect this information in a standardized way. So you will see an example of how to use it. So let's continue, and the next step of the compilation process is the reference database. And the reference database is where the compiler manages the food composition data. So here is where we are going to have most of the work to develop or to update a food composition table, because at this level of the food composition data management, we are going to put all the similar foods together and then compare the values, evaluate in detail the information that we have, complete the missing values, make all the calculations and the standardizations that we need to have a good quality food composition table. So here is where we are going to spend most of the time during the management of a food composition database. And then the last step in the management of food composition data is to prepare the user database. So the user database is a subset of the reference database. It represents only the information that we want to make available for the users. So the user database can be either a small set of data or a very comprehensive database with lots of information and also documentation for the user. So it will vary depending on the aim of the food composition table. So as you can see, the compilation process includes all these 4 steps, and it's really important that we follow each step because it makes it easier for us when we need to go back and check the information that we are going to publish on the user database. Because if we take the original data and then we start to make all our calculations, aggregations, and estimations, and we don't keep the original data recorded as it is in the archival database, it will be very difficult if we need to check or to make an update of this food composition table. So it is extremely important that we keep all these different steps. And as I promised, I will show you a real example in my Excel files for you to see what is the difference in a practical example among the different steps of the management of the food composition data. But before I show you the examples, I just want to let you know that if you want to learn more about the compilation process, you can find more information and also an example using the compilation tool in Excel in the FAO in Foods e-learning course on food composition data. So in the Unit 5, you will find the compilation process and you will see an exercise that includes all the 3 different levels of compilation. So the archival database, the reference database, and the user database. So it can be also very useful for you to learn by doing. And also, if you want to read more about the compilation process, you will find a lot of information in our Bible, the Greenfield and Southgate book on food composition data, and also in the study guide. Module 9 is dedicated to food composition database management systems and data interchange. And if you want to access all these publications, you can go to the Food Composition Explained website. I will leave the link down here in the video description, and you will find the link to access all the documents that I have mentioned here, including the FAO in Foods compilation tool. So now let's go to our practical examples. Okay, so now let's go to our real example. So I will show you all the files and how I have organized the data to compile the global food composition database for pulses. I will leave here the link also for the food composition database if you want to access to see the final result of this compilation. So in the first step of the compilation process, I did the collection of the data sources. So the main source of data that we have used were scientific articles that we could find in the literature. So to start with this literature search, I will show you here. I used Scopus to make the search. This is just one of the websites available for making the search. I like to do using Scopus because I think it is a very comprehensive website. So when you make the search there, you can download the results in an Excel file, and this is what you are seeing here. So I like to add here at the beginning of this, in the first line of the spreadsheet, the keywords that I have used to perform the search. So in this case, for this food composition table, I was interested only in pulses. So I did a search for each of the pulses that I wanted to include in the food composition database. And since it was a global food composition table, I was not limiting the search according to the country. So I was taking all the data available for any country in the world. So here's the result. So Scopus show us a spreadsheet with the details for each scientific article. So we can see the authors, the title, and one of the details that we have here is the abstract. So I have used the abstract to select the articles that could have analytical data of my interest. So I added at the end some columns, as you can see here. So this one is to indicate if in fact the article have analytical data to be compiled or not. So after evaluating the abstract, I could identify if we have data to compile or not. So you can see here that in many cases there were no data to compile. And in the cases where I had data to compile, I did the complete evaluation of the data quality and if all the information that we need to compile an article was presented in the full publication. So as you can see here, let me just select all the yes here where we have data. And as you can see here in the next column, I was always assigning if I could compile or not the article, and under comments the reason why I could not compile the information. So I did it for all the different articles that we could find for all the different also pulses species. As you can see here, I have a different spreadsheet for each type of food that I wanted to include in the database. And then every time I could compile an article, the article would receive a code. So you can see here that each compiled reference has a code. So all my references were starting with the letter P and U, and then a three digits code. So I did it for all the compilation. So I could name the file for this reference with this code, so it would make it very easy to access the original publication if needed. So the information will always be indicated, associated with the code of the original data, so we can go back easily if needed. So this is what I did in the level of the data sources. So let's see the other spreadsheet where we have the archival and reference databases. Okay, so here in this spreadsheet we have the archival database. So here we have all the species, all the entries that I could compile for pulses. And as you can see, this spreadsheet was adapted from the FAO in Foods Compilation tool. So we have here all the information that is needed, and here we have all the different tag names associated to the components. So just to give you a quick overview, so I always, as I told you, here under the biblioid, I put the code that I gave for each scientific article associated to the line of data. So you can see that in some articles I could compile only one line, but in some articles we had a lot of different lines. Here, and we go for the reference number 50, we have all these lines compiled. So it is important to associate each line of data with the original data source. So if we need to go back, it will be easy to do it. And also for all the different, once I finish the compilation for all the different lines, I add an internal code that is for my use. So when we go to the next level of the compilation, that is the reference database, we can also link the two lines of data if we need. Then here we have some of my quality control, so the sum of proximates, sum of amino acids when it's available, sum of fatty acids, and sum of minerals, just as an internal check to verify the quality of the data that was compiled whenever possible. And then we have all the different tag names. So when I compile the data already assigned the correct tag name, it will make much easier in the next step when I need to aggregate all the information, because we know that all the components, all the values that are below the same tag name, they are equivalent and they could be easily combined in an average value, for example. So this is the archival database. So here we have exactly the information that was provided by the original source, in addition to my checkings. That's the only calculation that we do here. And also, of course, I have already standardized the units and denominators. So as you can see here, for example, protein is expressed per gram. So all the values that are below the tag name here in this spreadsheet, they must be expressed in grams. So same thing for minerals. So we need to be careful and check here if for all the minerals we have the correct units, if they are expressed in milligrams, for example, for copper. But if I am compiling, for example, selenium data, it should be in microgram, and same for vitamins, and the same for all the different components. So they need to be standardized in terms of units and also in terms of denominators. So it's very common that we find in scientific articles the data expressed per 100 grams of dry bases. So in this case, we need to have the moisture content in the food to convert to the fresh weight bases. And it should always be expressed per 100 grams of edible portion. So not per kilo, for example, or per gram of food. It should be expressed per 100 grams of food. It is very common also that, for example, amino acids are expressed per gram of protein or per gram of nitrogen. So we also need to convert to per 100 grams of food in a fresh weight basis, and the same for fatty acids. It's very common in scientific articles that, for example, the fatty acids are expressed per 100 grams of fat or per 100 grams of fatty acids. So we need to pay attention to this kind of details to standardize the units and denominators, and that's the only change that we do here at the archival level. In addition to the data compiled from these scientific articles, I have also collected data from other food composition tables, and I put it in a separated spreadsheet just for me to know if the data was original analytical value or if it was from another food composition table. So I have also compiled all the different food composition tables here using the same format with the same columns in all the different levels of the food composition table, because then we can copy and paste from one spreadsheet to the other one without any problem. So now I have here the archival database from with data from the scientific articles mainly. We also have received some laboratory reports, but we use it mainly data from scientific articles. So here I have the data from the other food composition tables that I use it mainly to fill the data gaps from the original analytical values that I have compiled. And here finally, we have the reference database. So the reference database is where I told you that we have all the main work of the food composition table. So here is where we put together the similar foods that we want to aggregate to create an average value, for example, and is where we compare, we judge the quality, we check the outliers, we also fill the missing data, and we make all this calculation. So here I will show you an example of the aggregation for one food. So here you can see the black beans. So I came back here in the archival database and I tried to find all the phaseolus vulgaris that were described as black beans. So this is what I did. I took from all these compiled foods, and you can see that the list is very big. So here I took only the beans that were described as black beans, and then I put them here in this spreadsheet all together. And here you can see that I have added the lines to make the data aggregation. So here I have one line for the average values, for the median, minimum, maximum, standard deviation, number of data points that were used to create the average value, the value documentation, and one line for any comments, any relevant comment in the data aggregation. And then when we go here to the different components, you can see that the calculations are here. So for example, here I took the average value for water, I have excluded some values and the reason is documented here. I have also filled all the data gaps, so you can see that the columns that are highlighted here are the ones that I need to add the data that I want to present in the final food composition table. And this is what we do here in the reference database. So we do all the calculations and we check all the different values that could be compiled to create our food. So this is the foods that we want to present in the final version for the users. And of course, in my case, I also presented all the statistics that you can see here. So basically, this was the information that was presented to the users, and of course all the different columns that were not of interest for the final food composition table were also excluded. So this is how then we prepare from the reference database the final user database that we are going to present to the users. So then, just to show you the complete process here, you can see that this is the user database for the pulses. So here we have only the average values. So for each food here we have all the different components that we wanted to present here in the food composition, the final food composition table. And we also have the nutrient values with the statistics. So here we can see the statistics as you could see in my reference database. So this information is also here, including the comments that I have added to this spreadsheet. So this is the difference between the reference database and the user database. So here we have only the information that we want to present to the users, because this is what is useful for them. Well, so here I want to show you the importance of keeping this separated levels of management of food composition data. So if we go here, for example, to this food, we have here the code, the internal code that I told you that I always give for each line of data. And we also have here, let's see, here the biblioid, the code for the given food. So where did I took this food from? So this is the code of the scientific article where I took this food, where I compiled this food. So if for any reason I did any change or I need to check any information, I can look here in the archival database. I can search by the code of the food and I will see here. So common means solid black, so is one of the black beans that I was compiling there, and the food code, the reference code is this one. So if we go to my first step where I collected the data sources, I can look also for this code there, because I have it noted here. So P271, so I know that this is the reference. This is the title, the authors, the source, the journal where it was published. And because, as I told you, I add this code to the name of the file of the original source, I will show you how it is easy to come here and to search. Here I have that this is the original source, this is the line, the number of the line, and the author and the year. So if I need to recover or to check any information from the original source, I can easily recover the information. So this is the original source of that food. So it's extremely easy to go back and to check and to document everything. So this is why it is important to keep track of all the single values that you have in your archival and reference databases, because you need to be able to explain all the values that you have in your Excel file. Well, so that's all for this video. Thank you for watching and I hope you found value in it. And if you are interested in learning more about food composition, I really recommend that you access our website. The link's down here in the video description. And if you have any questions or topics that you would like me to cover, please write down here in the comments below. Thank you for watching and see you in the next video.